All right, well, continuing on chapter 11 then. So the next thing we're going to do in this discussion of probability and related concepts is talk about what's called odds. Odds is similar to probability. It's creating a ratio that is going to tell you a relationship, but it's a slightly different relationship. So first thing is we have odds against an event. So odds that an event does not happen. So the way you would calculate the odds is like this. The odds against an event is the probability the event fails to happen in the top divided by the probability the event succeeds or does happen. So notice slightly different in our ratio. Probability, if you remember from last time, probability is the ratio of success to total. Okay, so odds is a different relationship. Odds against is the ratio of failures to successes. So for instance, my example, determine the odds against rolling a 4 on one roll of a fair die. Okay, so the odds against. Okay, so the odds against this happening. Well, first, it's going to be the probability that I fail to get a 4. So what's the probability that I do not get a 4 on a die? 5 out of 6, right? There's 5 sides that are not labeled 4 out of 6. Everybody with me? Let me know. Be bold with your questions, please. So then divided by the probability of success. What's the probability I successfully get a 4 when I roll my die? 1 out of 6, perfection. Just gonna pause for a second. When you're doing your odds, you're basically failure and success. Those are the only 2 things that can happen. So these things, these fractions, these probabilities, they should add up to 1 because that's every possible thing that can happen. All right, well, I don't know how much you remember or like about working with fractions. When I'm dividing fractions, remember what you do is this. You take the top fraction, you leave it alone, and then you multiply by the reciprocal of the second fraction. So you flip that second one around, 6 over 1. Now the 6's will cancel. When you're doing your odds, that's pretty much always going to happen because we are dealing with things that only have an equal chance of happening. And so what we get is 5 to 1 odds. What this is it's the ratio of failures to successes. So it's slightly different than probability. Okay, so we have 5 failures for every 1 success. Now, when you deal with odds, you leave the 1 in the denominator. Okay, so people know that it's odds. More commonly, odds are written like this, 5 with a colon 1. Okay, or you might say something like there are 5 to 1 odds against this happening. Okay. I will most normally use this notation here with the colon. I think that's the notation my math lab uses, but always follow their directions. Okay. So that's odds. We're using probability to create a new ratio. So what I would like you to do, in addition to asking any question that you have, do exercise 1. What are the odds against rolling a number less than 3? All right, so the odds against. The probability of failure, probability of success. This time, I want to know what are the odds against rolling a number less than 3. If it helps you think about it, you might do the successes first. What's the probability I successfully pick a number less than 3 when I roll, or get a number less than 3 when I roll my die? So what's the probability I get less than 3? 2 out of 6. Okay, that's my probability of success. What's the probability I fail to get a number less than 3? So that means 3 or more. So that is the other 4 out of the 6 options. Remember, when you're doing odds, these two things are always going to add up to 1. So that's a nice check to make sure that you've done both probabilities right. So once again, going to go through the process. I've got 4 over 6 times the reciprocal 6 over 2. These 6's are going to cancel. You end up with 4 over 2. You could have reduced that all at once. I'm just trying to do one thing at a time because I know we don't love decimals, so, or excuse me, we don't love fractions. So 2 goes into the top and bottom, 2 goes into 4 twice, 2 goes into 2 once, and I have 2 to 1 odds. There are 2 to 1 odds against you, meaning you have 2 failures for every 1 success. Okay, that's how you interpret odds. You get 2 failures for every 1 success. All right, we're just going to practice this. This is basically the whole section is calculating odds. There's one other thing we're going to talk about here, but this is the bulk of it. So do exercise 2. Okay, so there's some billiard balls in the picture, the different colors and different numbers. So exercise 2 says if one ball is selected at random, what are the odds against it being green? Okay, so what's the probability that I succeed in picking a green ball? Okay, there are 2, yes, out of 15. Okay, one has green stripes, one is just solid green. I didn't specify stripes or solids, just green. And then, so that means the probability that I fail to get a green ball is perfect. You're doing great. If you're not doing great, if you're not seeing where these probabilities are coming from, please, okay, ask questions. Just a few of you in the class. We can answer every question that you possibly could have and have time left over, okay? So don't be shy at all. So we've got 13 out of 15 and then 15 over 2. The 15s cancel and I have 13 to 2 odds. Okay, so that is 13 failures for every 2 successes that I have. Okay, next one. Exercise 3, just another one with the same billiard balls. So go ahead. This time it's the odds against a number less than 5. right, so the odds against, one more time. Probability of failure divided by the probability of success. So again, my brain works good when I think about the successes first. So what are the odds against a number less than 5? So what is the probability that I get a number less than 5? Well, there's a 1, 2, 3, and a 4 there. So they're all included. So 4 out of 15. Then the other 11 billiard balls are 5 or more. And so the 15s, I think you probably at some point can see the pattern that if you need to keep rewriting the multiply by the reciprocal, bless you, then you can, but the pattern is you can see that these denominators are just going to cancel because they're the same thing every time. So there's a shortcut, but if you don't want to take the shortcut, that's totally fine. So we have 11 failures for every 4 successes. Are we still doing okay? Sure, bring it on. Hadn't simplified it how? Oh, yeah, minor deduction. You always need to reduce your fractions. Yes, but if you did that on the test and just forgot, you're going to get the bulk of the points because you did most everything right. Okay, so it's not a case of being right or wrong. It's just a case of getting it to the final form. All right, exercise 4, same sort of thing, this time just with a spinner. So odds against your spinner landing on green. Morning. All right, so the probability that I successfully land on green is 3 chances out of 8. So then the failure is the other 5 spaces out of 8 are red or yellow. And so again, I'm going to multiply by the reciprocal, or you can skip this step, and I get that the odds are 5 to 3, meaning 5 failures for every 3 successes. All right, going to flip the page. This next thing is absolutely nothing new. It just turns out to be the reciprocal. So you can also talk about the odds in favor. Just depends on what perspective you want to take when you're calculating your odds. So notice the odds in favor are just the reverse ratio. This time we put the successes in the top. Okay, so favor means success in the top. Against means failure in the top. It's the same sort of ratio. So there's really nothing new here. In fact, once you've calculated the odds against, let me just go back. You don't have to turn your page. Once you've calculated the odds against, you also know the odds in favor. So for instance, exercise 4, if I then asked you in the B part, what would the odds in favor of a green be? So odds in favor, you don't have to do any calculating at all. If my ratio is 5 failures to 3 successes, that means the odds in favor are going to be 3 successes to 5 failures. So it's just the reciprocal arrangement. So there's no new calculations that you have to do. So you'll notice in this problem that I've given you to do here, my purpose for this problem is to make sure you're latched onto the difference between probability and odds. So the first two problems are asking you to calculate the probabilities, and then you're going to calculate the odds against, and then the odds in favor is just going to be a simple switcheroo of the fraction. So I'm going to give you a minute or two to work through exercise 5. All right, in exercise 5, we're told that Anne has 12 bills in her wallet. It's good to be her. 6 are $1 bills, 2 are 5s, 3 are 10s, and a 1 $20 bill. So first off, what's the probability if she randomly goes into her wallet and selects one? What's the probability that it's a $5 bill? So tell me, what is that going to be? 2 out of 12, the total number of bills. Remember, probability, and this is, if anyone else stumbled on this, totally good. That's why I asked this problem, because I expect it. Probability is successes divided by total. Okay, so always remember that. I understand that it can get a little conflated in our brain. So there's 2 $5 bills out of 12 total bills. Okay, so that becomes 1 out of 6. I'm just going to leave it as a reduced fraction. So then what's the probability she does not select a $5 bill? So everything else. So how many not $5 bills are there? There's 10 out of the 12. Great. And so then that reduces to 5 out of 6, because 2 will go into both of those. 2 goes into 10 5 times. 2 goes into 12 6 times. Now I'm ready for the odds against. The odds against is the probability of failure divided by the probability of success. And the good news is we've already calculated those things. So there's nothing new on this problem. The probability that I fail to get the $5 bill is 5 out of 6. The probability that I succeed in getting the $5 bill is 1 out of 6. And so that becomes 5 to 1 odds. So 5 failures for every 1 success. Again, I'm going to write that right here so that you remember that this is the ratio. When you have odds against, it's 5 failures for every 1 success. And then the new little bit is, okay, what are the odds in favor? Odds in favor just flips that around. So what's the answer to this last one? 1 to 5, perfection. No calculations needed because we've already done the odds against. All right, one more odds in favor problem, and then we just have a problem going the reverse direction, and that's how we'll finish up this section. So in exercise 6, you are going to select 1 card from a standard deck. What are the odds in favor of a queen? Okay, odds in favor of a queen. I'm sorry? There's 52 total cards in a deck of cards, yes. So just making sure reading comprehension, this one asks for the odds in favor. So make sure you pay attention to that. And odds in favor are the probability of success. That goes in the numerator divided by probability of failure. So what's the probability I successfully draw a queen out of the deck of cards? Perfect. 4 out of 52. Wonderful. So 4 divided by 52. So then that means all the other cards are failures. So 48 out of 52. So I will multiply by the reciprocal. I've got to do a little reducing here. So first the 52s cancel, and 4 will go into both 4 and 48. So when I reduce that, 4 goes into 4 one time. 4 will go into 48. Your calculator will tell you 12 times. And so my odds in favor are there's 1 success for every 12 failures. Okay, so again, that's what this ratio is telling you. I'm going to abbreviate success and failure. That's what that ratio is telling you. Probability is success to total. Odds in favor are success to failure. Okay, so I've got one more example. You've got 2 more in this section, and any questions, and then we'll get started on the other section for the day. So example 2 says this. The odds against Robin being admitted to a particular college are 15-4. So determine the probability. So this time we're going backwards. Okay, we're starting with the odds and we want to form from that the probability relationship. So real quick, remind me, because this makes all the difference. This is the odds against. I'm going to underline that, or let's circle it just to be even more bold. The odds against. So that means the 15-4. The 15 then represents what? Failures. And then the 4 has to represent successes. Okay, so from that, I need to find the probability that Robin is admitted. So the probability that Robin gets into this college. Okay, remember, probability is success divided by total. So what's the number of successes Robin has? 4. Okay, that's just right from my odds. 4 successes. Now here's the key. Out of how many total? 19. Failures plus successes gives me my total. That is 19. And we are done. You tracking with me on that problem? All right, well then exercise 7 is very, very similar for you. So go ahead and give it a try. So just notice, I'm just trying to make sure that you don't get lulled to sleep here. So this one, I gave you the odds in favor. Okay, so just keep that in mind. So that means since it's odds in favor, the 3 represents successes and the 10 represents failures. Okay, that's the ratio. So if Mark is going to, or we want to know what's the probability Mark's going to sell this motorcycle, what's the numerator of my probability going to be? Okay, 3. And then the denominator is going to be perfection. Great job. 3 out of 13. I'm just leaving these as reduced fractions. You're welcome to give me decimals. Please round to the 3rd or 4th digit. I prefer the 4th, but I wouldn't take off if you rounded it to the 3rd because I'm pretty sure that's what my math lab has for you. All right, last problem. All right, so I looked up online when I made this problem that after the All-Star game, if you're a basketball fan, the Golden State Warriors, their odds against winning the title were 9-2. So what's the probability that they win? So this is odds against. So that is failures to successes. So that means the numerator of this probability is going to be what? 2 chances out of 11 total opportunities. And there you go. That is odds against and odds in favor.